computer program is a list of instructions that can be followed by a computer to perform a specific task. Most programs work by taking some input data, processing that, and creating some output data. Understanding the values and types will form a foundation on top of which we can build up concepts that will allow us to write our own programs. So values are the actual underlying raw numbers and text our program manipulates. Tony Stark, the number 43, and false are all examples of values. Sometimes we'll say that when we literally write the number 4 and then the number 3 next to each other to form the number 43, that we're writing the literal 43. Same with Tony Stark. If we write the quotes, then the letters T, O, N, Y, etc. into our code, we'd say that we're using the string literal Tony Stark. Sometimes we might say that this is hard-coded, meaning that when the program runs, the literal value isn't going to change. Literal values are used a lot when you're first starting out, but eventually data will likely come from a database or some user input. Every value belongs to exactly one data type. The kinds of values that can be represented and manipulated in a programming language are known as types. All of these literals that we've written so far can be categorized as a specific type. We see string, number, and Boolean. Those are the types for Tony Stark, 43, and false. Most languages use a very similar list of super simple types, like a collection of characters as a string of text, a list of digits with or without a decimal point as a number, and then some type for representing true and false. Some programming languages will have more types that they have built in. Other programming languages will have a very small set of these primitive built-in types that you are to use to build up to more complex types. When a program needs to use a value again in the future, it assigns that value, or sort of like stores that value, in a variable. Variables have names, and they allow us to use those names in our programs to refer back to the values. We'll talk more about variables later. Here we're assigning the value 7 a name, age. We're also assigning the string Grayson to the variable name first name. If we wanted to print out the value 7 using the variable age, we might call some print function and pass in the variable name or the literal number 7. And we'll take a look at how to print out the number or the string or whatever value it is in different programming languages. There's really two different kinds of types. There are built-in types, and then there are user-defined types. Built-in types are the types that come with the language. This is the batteries included stuff like numbers and strings and dates and arrays and object types. User-defined data types are defined in terms of built-in data types and other user-defined data types. Here, we're defining a student type, or we have defined a user-defined type called a student type, which is composed of or made up of other built-in types, the number for the age and the string for the first name. We might also create a car type, which takes in a make and a model, both of which might also be user-defined types. Typically, a programming language does not let the programmer extend or redefine those built-in types. Next, a type can either be mutable or immutable. These primitive types like 7 and true are immutable, meaning they cannot change. You can change the value of the variable, meaning you can change what the name of that variable is referencing by pointing the variable at a different value. However, there's no way to change what the number 7 means. When we talk about the number 7, there's no way we can modify the number 7 to be the number 8 or the number 6. We wouldn't want to change what the number 7 means. Similarly with true, we wouldn't want to change what it means for something to be true. A mutable object can change. So if you head over to REPL.it and you fire up a new Go REPL, this is the boilerplate that it will add for you. At the top, we're defining this package and calling it main. We are importing the FMT or the format package, and then we have a function defined here called main. In main, we are calling format.println and then passing in the string literal hello world. All right, so it already comes with hello world. If we were to delete this and put in Tony Stark, let's see what happens when we attempt to run this code. Well, notice that we get back an error, and it's really important to try to understand and read these error messages and see what they're saying. So here it's telling us that in the file main.go, so main.go is the file name, and then it has a colon, and after the colon it gives you the line number. The first number is the line number, so we'll see that we're working on line 6. And then 20 is generally like the character number. So line 6, if we go in like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. It thinks S for Stark is unexpected. It's saying unexpected Stark, expecting a comma or a closing parentheses. That's because it thinks that it's trying to print out Tony, which might be some variable or some constant, some reference to something. It doesn't know yet that we meant to print out a string. So in Golang, we need to tell Go where the string is beginning and where it ends. And we do that with a double quote. So we put a double quote at the beginning of the string and a double quote at the end of the string. And that will tell Go what like literal that we've written here is part of that string. So here we're saying format.println, and then we're passing in this string literal Tony Stark, and that's what we actually want it to print out. And you'll notice that it prints out now Tony Stark. The next thing I want to talk about is comments. So generally we use comments to describe bits of code or to talk about why and to like remind our future selves of why we did certain things certain ways. We can also use comments to remove code so that it's not executed. And we might say that something is commented out when we put the / in front of the line to make it so that certain bits of code are not executed. And then we might say that something is commented in when we remove the comment line beginning. So here we're going to comment out this line so that we can keep track of things that we've already demonstrated, and then show just new code down below so that if you want to refer to this later, you have all the different steps that we talked through. So I am commenting out this first line that we executed, format.println Tony Stark. The next thing I wanted to do is just show how we can print out a number literal. So let's print the number 43. So if we put in the number 43 and execute, we'll see that number 43 is printed here to the console. Next, we might even print something like the evaluation of some expression. So we might say 43 plus 10, and we want to print out 43 plus 10. So we know this is going to print out 53, right? But how is this actually happening? Well, the number literal 43 and the plus operator and the number 10 form an expression. So 43 plus 10, this is an expression. And that expression, when the code is being executed, this expression will be replaced by the value this expression evaluates to. So as the code is running, it will see 43 plus 10. It will do the math. 43 added to 10, you get back the arithmetic result being 53. Then 53 is what's passed into println before println is actually showing 53 in the console. What happens if we try to add two strings together? So if we say Tony plus Stark and execute that, let's see what happens. We get back the word Tony Stark with no spaces between. We get the first name and last name. They're kind of smushed together. This is called string concatenation. So the plus operator in this case is concatenating or combining two strings. Concatenation is the linking of two things together in a series, or the linking of things together in a series. So in this case, we are taking the string literal that we've hard-coded, this string Tony, and we're adding it to and concatenating with the literal string Stark. Now, if we wanted to have a space in between there, we might do something like, let's add a space to the end of the word Tony and concatenate Tony space plus Stark so that we get first name plus last name. Another alternative would be to concatenate with yet a third string literal here that is just the space. So we can say Tony plus the string that is just the space plus Stark, and this will achieve the same result of having the space between Tony and Stark. All right, let's take a look at how we can inspect the type of a value. So if we have a value like 43 or a value like the string Tony, we might want to know, is this a number? Is this a string? Is this a floating point number? So we didn't actually talk about that yet. So let's see what a floating point number might look like. So we've already talked about printing out 43, and we know that that works and that prints out the number 43, and that is an integer. It is a whole value, whole integer. But we could also say 43.0123, and this is going to be a floating point number. So we get back 43.0123. So there's different types of numbers, and how they work together is defined by their types. And so we have an integer type and we have a floating point type. And they have specific precisions, meaning like how precise can you get with this floating point number? And we'll talk about that later. But for now, I wanted to show how you might reflect or how you might inspect the type of a value. Let's use the printf method on format to print out a string with formatting. So printf allows us to specify a format string as the first value, or as the first argument to printf. And the second argument to printf is the value that we want to print out. So there is a format specifier called %t, which says take the type of the value that we're passing in as the second argument and use that, determine its type, and print out that type. So if we pass in Tony as the second argument to printf with the %t format specifier, we get back the value string. There's another way that we can inspect the types of objects here, and that is by using the reflect package. But first, let's take a look at what we get when we inspect the type of 43 and 43.123. So for Tony, we're going to get string. For 43, we get int. And then for 43.123, we get float 64. It's kind of difficult to see because format or printf does not add a new line character to the end. So let's add this \n, which means add a new line after we print out the format of the type of the object that we're passing in. So we get string, int, and float. That's pretty cool. So that's one way to inspect the type of a value. Next, let's import another package called reflect that we can use to inspect the type of a value. So here, generally, if we're importing multiple packages, we will add them on new lines, and then we'll wrap all of the imported packages in these parentheses. And the package we're going to use now is called reflect. Reflect allows us to inspect the type very similar to using the %t here. So let's just copy these three. And then instead of printf, let's say print line. And then instead of any of the formatting, we're just going to print the reflection of these values. So we say reflect. We say reflect dot type of, and then we pass in the value that we want to inspect the type of. So we'll use this for 43 and 43.123 and see what we get back when we run that. And it is the same output as if we had used printf with the %t format specifier, but we're just using reflect now, which is another way that we can inspect the type of a value. Now in practice, when you're hard coding a literal, like the literal string Tony or the literal number 43, you know what the type is because you just typed it. And it's right there, it's hard coded. But if you have these values stored in variables, so if you have just the name that represents the variable that's already been stored previously, maybe in a different file, and you don't necessarily know what the type of that variable is, it could be useful to inspect the type to have some logic based on whether the object is a string or if it is a floating point number with 64 bits of precision. So this is here are a couple different things that you might want to do with values in Go.